I'm Anil Kumar, and in this video we'll do differentiation of inverse of tan function using substitution technique. Here is an excellent question. We need to differentiate y equals to tan inverse 2 to the power of x plus 1 divided by 1 minus 4 to the power of x. Now the idea is, within this bracket we need to get something in tan. Now if you have explored formulas for tan, you will notice that we do have a formula for tan which is kind of like this. Tan 2 theta is equals to 2 tan theta over 1 minus tan square theta. So we'll try to write this in that form. So let us see what substitution works best for us. We need to replace something by tan theta. That's what we know. So first I will rewrite this formula. Let's say y equals to tan inverse. And within brackets, I can write 2 to the power of x plus 1 as 2 times 2 to the power of x. Denominator can be written as 1 minus 4 is 2 square, right? So we could write this as 2 square x. Right. Now, if I substitute 2 to the power of x as tan theta, then we can get this formula, correct? So let us make the substitution. So let 2 to the power of x be tan theta, right? So that is a substitution for us. We can now write down the question in terms of theta, which will be tan inverse 2 times 2 to the power of x tan theta, so we'll do tan theta, divided by 1 minus. Now 2 to the power of x is tan theta, so we get tan square theta here. Right. So the inside function can be written as tan 2 theta. So we could write this as tan 2 theta. Right? Now that gives you tan inverse of tan 2 theta will be 2 theta. So we have y equals to 2 theta. Now what is theta equals to? Theta is tan inverse of 2 to the power of x, right? So we could write this as 2 times theta is from here. Theta is equals to tan inverse of 2 to the power of x, correct? So we'll substitute this value for theta, which is tan inverse 2 to the power of x, right? Now we can easily take the logarithms, right? So this is what y is. Let me write it down on the right hand side. Then we'll take the derivative and write down the answer. So what we have here is now y equals to 2 times tan inverse 2 to the power of x. Now we know the derivative of tan inverse x is 1 over 1 plus x square, right? So we can find dy dx as equals to derivative of all this d dx of 2 times tan inverse of 2 to the power of x, right? So that is 2 is a constant. Derivative of tan inverse x is 1 over 1 plus x squared. So we can write this as 1 over 1 plus x is 2 to the power of x, right? So we get 2 to the power of 2x times derivative of inside function, right? Times derivative of 2 to the power of x, right? So that is what we get. So this could be written as 2 over 1 plus 2 square is 4 to the power of x. Derivative of 2 to the power of x is 2 to the power of x ln 2, right? Now this could be written as 2 times 2 to the power of x, which is 2 to the power of x plus 1, divided by 1 plus 4 to the power of x, the expression which we have here, times ln 2, right? So that is how we can actually find the derivative of the given expression. It is important to see how we manipulated the values, simplified them, and did the right kind of substitution to find the derivative. I'd like you to go through this video once again, try to understand all these steps. I hope it makes some difference in your solution of problems. You can always share and subscribe my videos. Thank you and all the best.